Humans have long harbored the dream of venturing beyond Earth and exploring the vastness of the galaxy. Many believe that we arrived on the cosmic scene too early to be a part of such a grand endeavor. But what if that assumption is mistaken? What if the time is now? In truth, we stand at the precipice of turning this dream into reality by constructing a moon base. Remarkably, the technology required for such an endeavor is within our grasp. Estimates from both NASA and the private sector suggest that a moon base could be established for a cost ranging from $20 to $40 billion, spread over roughly a decade. This investment is comparable to the budget of the International Space Station or the surplus of Germany in 2017, relatively modest considering the potential payoff. Building a moon base would not only be a monumental achievement in itself, but also a stepping stone towards even greater feats. The moon offers us a sandbox to develop new technologies and tap into virtually limitless resources. It could ignite a new space race, expanding our reach into the solar system and beyond. The technological advancements made during this endeavor would not only benefit space exploration, but also find applications that improve life on Earth. So, why haven't we embarked on this journey yet? The unfortunate truth is that governments are often hesitant to make long-term investments in the future of humanity. But just imagine if we did. If we were to begin today, how would we go about building a moon base? Throughout history, colonization has occurred in phases. European monarchs, for example, funded expeditions to chart and claim new territories. They established outposts and settlements, gradually forming colonies where people could emigrate and create new wealth for themselves and their nations. When we colonize the moon, we will undergo similar phases, but without the tragic consequences of the past. The moon, however, is not a hospitable place for life as we know it. A day on the moon lasts 29 Earth days, with extreme temperature differences between sunlight and shade. The lack of atmosphere exposes the surface to meteorites and cosmic radiation. Despite these challenges, we have the knowledge and technology to overcome them. The first phase of lunar colonization, exemplified by the Apollo missions, has provided us with valuable insights and paved the way for the next steps. In the next phase, astronauts would establish the first moon base. This could start today, with a small, inflatable habitat accommodating a crew of up to 12 people. This initial base would be light and located in a naturally sheltered area to minimize costs and maximize safety. As the base grows and becomes self-sufficient, it could serve as a hub for economic activity, mining resources, and exporting them back to Earth. This would not only ensure the survival of the colony, but also open up new possibilities for humanity's future in space. The colonization of the moon represents a pivotal moment in our history, a chance to expand our horizons and secure our future as a species. It's a project that could unite nations and propel us towards a future where the stars are within reach. The lunar surface is notoriously challenging, covered in a layer of jagged dust that poses significant obstacles. However, as a species, we have a history of overcoming daunting challenges. The first phase of lunar colonization, initiated by the Apollo missions 60 years ago, demonstrated that reaching a new world is indeed possible. Since then, satellites like the American Lunar Reconnaissance Orbiter and rovers like the Chinese Yutu have provided valuable data on the moon's composition, including the presence of water, ice, and metals. Phase 1 can be considered more or less complete, as we now possess the knowledge required to progress to the next stage. In the second phase, astronauts will begin construction of the first moon base, a milestone that could be initiated today. This base, envisioned as a small inflatable habitat for crews of up to 12 people, could be completed within a decade. The nation that establishes this base will be akin to the pioneers who built outposts in the New World 500 years ago. Given the high cost of lunar missions, efforts will be made to send as little material as possible. The base will be strategically located in a naturally sheltered area, such as caves or craters near the poles, where the days last for about 6 months. While astronauts will not stay permanently at first, their initial missions will lay the groundwork for future permanent habitation. The first crew will consist of scientists and engineers who will conduct experiments to utilize lunar resources. Water, in particular, will be a key focus, as it can be used not only for drinking, but also for growing plants and producing rocket fuel through electrolysis. By harvesting water from the Moon, we can establish an orbital depot that will supply scientific missions to Mars and beyond, significantly reducing the cost and complexity of these missions compared to launching from Earth. In conclusion, colonizing the Moon is not just a dream, but a tangible goal within our reach. It represents a crucial step towards our ultimate goal of exploring and colonizing the solar system and beyond. The Moon base will serve as a stepping stone for future missions to Mars and other planets, making space exploration more accessible and sustainable in the long term. However, at this stage, the Moon base is not yet a true colony. It remains dependent on Earth for funding and would be abandoned if financial support were to cease. To evolve into a fully fledged colony, it must become self-sufficient, supporting itself through exports to Earth. Private contractors are likely to play a significant role in this transition, seeking to capitalize on lunar resources and support services. Besides rocket fuel, they could extract precious metals abundant in impact craters and other raw materials from the lunar regolith. One particularly promising resource is helium-3, an isotope that could revolutionize nuclear fusion energy production. Another possibility is mining asteroids, which could be pulled into the Moon's orbit and then mined for their resources. With commercial exports to Earth, the colony would enter its third phase, becoming self-sufficient and economically productive. As the colony grows, it will increasingly utilize lunar materials for its construction projects. Lunar soil contains all the necessary ingredients to make concrete, and robotic mining rigs could be used to extract organic molecules and build large structures too massive to be transported from Earth. Advances in 3D printing will also play a crucial role in producing the goods and infrastructure needed by the colonists. The timeline for the colony to become fully self-sustaining is uncertain, but growth will be gradual. As the population grows to encompass more than just scientists, including engineers, pilots, and contractors representing various countries and corporations, the colony will undergo significant social and cultural development. A pivotal moment in the colony's history will be the birth of the first extraterrestrial child. Throughout history, the birth of the first child in a new colony has symbolized the establishment of a permanent settlement. This event will mark the Moon as not just a place for scientific exploration, but also a place for families to live and thrive. As the colony continues to grow, new technologies will be invented to sustain it, ensuring its long-term viability and opening up new possibilities for humanity's future in space. As the lunar colony continues to expand, its inhabitants may develop innovative agricultural practices, such as crops that efficiently recycle carbon dioxide or can thrive with minimal water. These technologies could have profound implications for Earth, addressing key environmental challenges. Additionally, the colony may pioneer advanced waste recycling systems, achieving a 100% recycling rate. Such technologies would not only benefit the lunar colony, but also be highly valuable for Earth, where waste management is a growing concern. One ambitious possibility is the construction of a space elevator, which would revolutionize transportation between Earth and the Moon. With a space elevator, Spacecraft, astronauts, and raw materials could be transported to and from lunar orbit without the need for rockets, drastically reducing the cost and complexity of space travel. The Moon could potentially become a hub for economic activity on a scale that is difficult to comprehend today. As the colony grows and develops, questions about its governance and ownership will arise. Will the first person born on the Moon retain the national identity of their parents, or will a new, unique lunar society emerge? When existing treaties regarding the ownership of the Moon are inevitably revisited, will the colonists have a voice in the decision-making process? Could they eventually declare independence from Earth? Regardless of how these questions are answered, the Moon serves as an ideal testing ground for learning how to colonize the solar system and beyond. It presents a unifying project for nations and offers a potential safeguard for humanity's survival in the event of a catastrophe on Earth. In conclusion, if we aspire to colonize the Milky Way and explore the depths of the universe, we must start somewhere. Why not start with the Moon? And why not start now? While immediate space travel to the Moon may not be feasible for everyone, there are countless opportunities to learn more about space and our universe, and we're here to help you do just that.